Okay, so today we will do the difference of two sets. We have now one example on difference of two sets. If X is a set of elements A, B, C, D, E, F, and Y is a set of elements F, B, D, G, H, K, then find X minus Y and Y minus X, and represent represent by Venn diagram. Okay, so first we will find X minus Y, then Y minus X, and then we will represent both X minus Y and Y minus Z in Venn diagram. To find X minus Y means X is A, B, C, D, E, and F. Minus Y is a set of elements F, B, D, G, H, K. Okay. Now we have to subtract the elements of Y from X, whatever is common. So F is here, F is here, and B is here, so B will be subtracted. D, D will be subtracted. G is not here, H is not here, K is not here. So what will be the left out elements will be A, C, and E. So our answer will be A, C, E. Okay. And now we will find Y minus X. First we will write Y, F, B, D, G, H, K. Then X. X is A, B, C, D, E, and F. Now common elements are subtracted. So then A is not there, B is there, B is there, D is common, D is common, E is not there, F is not there. So what is left? F is also there, F is also there. So G, H, K are left. So G, H, K. You get G, H, K. So now the two questions arises. We can draw a separate diagram for this one and this one, or we can draw same diagram which will represent both these things. So we can draw like this. Just draw one rectangle which will represent our universal set. This is our universal set, and these two sets are having common elements. So we will draw this is universal set. So you can write here universal set. Now draw two sets X and Y. We use to draw a circle. No, it should be a perfect circle, but here it's okay. We are drawing shaded. We are getting the shaded one. I will check if we can get without shade. No. So like this, we can have two sets. Yeah, we got. So I need this type of circle, not this one. So this is set A, and this is set B. Now we can write common element between these two sets. First, we have to draw the common elements of these two sets. This is X and this is Y. So between an X and Y, check what are the common elements between X and Y. So B is common, B is common. We can write B inside. Then B, D is common, D is common. So we can write inside. Just use one dot also. D is common, and the third element common is F. F is also common. F is also common. Okay. Then what are the left out elements in set X? A, C, E. So A, C, E anywhere we can write A, C, E. This is A, here C, and here we can draw E. Similarly, here G, H, K are left. So G, H, and K. So this is the Venn diagram. Now, but we have to show X minus Y and Y minus X. So see ACE is what? X minus Y. So this portion is X minus Y. So we can show by writing X minus Y is this portion, and this should be shaded with some color. So this X minus Y should be shaded, only X minus Y. This is X minus Y. So this portion is X minus Y. You can use your pencil to shade this portion. Like this, you can shade so that X minus Y should be visible and elements should be visible. You can use some pattern also. So this is the shaded portion which represents X minus Y. Okay. Then right hand side is Y minus X. You can see GHK. So this is showing Y minus X. So this is shade this one also. So this one we can shade with different colors. So this portion is representing Y minus X. Okay. So like this, we can represent X minus Y and Y minus X. If we have to draw separately, we will represent yellow portion only. And if we have to represent separately this Y minus X, we will represent this red portion. Okay, understood? So like this, we can find the difference of two sets. Now one more thing that is related to the difference is called, this is very important, generally in 1 mark is going to be asked every time. So a symmetric difference of two sets. Symmetric difference of two sets. That was the difference. This is called symmetric difference of two sets. So you have seen A union B, union you have seen, difference you have seen. This is the combination of difference and union. If you have the two sets, let A and B be any two sets, then be any two sets, then their symmetric difference is represented by then their symmetric difference of A and B, that is symmetric difference is is their symmetric difference is the set A minus B. First you will find A minus B in his left portion and union B minus A. So that both portion, union of that both portion, believe not sorry, believe this one we have seen this yeah, this portion. X minus Y is this yellow portion and this is red portion. The union of these two. That means A, if I will find here, okay, so if I will find X minus Y, okay, union Y minus X. So what will be the element? This third union means addition. So all these three and these three elements will be combined. So A, C, E and E, H, K. So you can take this example. So this is called symmetric difference. Asymmetric asymmetric difference B. This is called X symmetric difference. X symmetric difference Y. So asymmetric difference B. Okay, and it is denoted by the symbol denoted by A delta. We used to say this is also a delta. There are two types of delta. This is also a delta. This is also a delta. Okay. This is, yeah, like this delta, and this is also read as delta. So A delta B means it is the union of A minus B union B minus C. This is called symmetric difference. If the question is find the symmetric difference between A and B, so you'll write like this. And this is the set of all elements which are in A or B, but not in the intersection. You have seen that these elements are not in the intersection. So except the intersection, it belongs either A, either X or B. So its definition will be it's a set of all X such that X will belong to A or it will belong to B, but it will never belong to intersection. But X will not belong to A intersection. Are you understanding? A intersection B. Okay. So this is called symmetric difference. So we can show easily what will be the if I want to say without having any elements the symmetric difference in Venn diagram. So we can see yes, it can be represented by simple we can have this one universal set and draw two universal sets and then take two one circle can have another circle and represent their shaded portion only. If it is big, take same size, but for this shaded portion, as we have seen this shaded portion, this one shaded portion of this part, shade this part, and this part. So, like this shaded portion, we can present as symmetric difference of A into B. Okay. Shading should not come outside. Okay. So this will represent what? A A symmetric difference B is represented by this Venn diagram. So that you have seen. Now there are some very important law of difference of sets. Means there are some relations that you have to remember regarding the difference of sets. So for any two sets, so this is called law of difference of sets. Law of difference of sets. So symmetric difference, you can find the symmetric difference. We have to do some questions also, but now we are completing this some topics. Then we can have more questions. So law of difference of sets for any two sets, for two sets and three sets. So for two sets we have, for any two sets A and B, we have number one. Remember it, very important. A minus B is what? A minus B is nothing but A intersection B complement. Complement will be, I'll tell you, complement will come now afterwards. But complement means except this set. If this is a Venn diagram, suppose this is a set and outside this is set A, then complement will be A dash outside this. The element which will belong to the universal set. Means A complement is what? Universal set minus A, you can say. Okay, so this will come in the next topic. So there I will explain more about it. So complement means accept this all elements in the universal set except the elements of B, and it is denoted by dash. So A minus B is always equal to A intersection B complement, and B minus A similarly, B minus A will be the intersection of B with A complement. Okay, so we can see some more properties. There are many properties. Actually, it is very vast chapter. There's so many things. If we study deeply, it will take more time. So A minus B is always a subset of A. Fourth, B minus A is a subset of B. Always it will come inside the B. So it will be a subset of B. Fifth, A minus B. If A minus B is equal to A, then that means this implies by that A intersection B is a null set, means disjoint set. This will also come next part. Sixth property A minus B. If you will take A minus B union B, A minus B union B will be equal to A union B. A union B. And seventh property is A minus B intersection. A minus B intersection B will be nothing. Is a null set. And the last property, eighth property is A minus B. A minus B union B minus A, that is symmetric difference B minus A. It can also be written as A union B, A union B minus A intersection B, because intersection is just excluded. And for three sets, for three sets A, B, C, we have first property A minus fifth property A minus B is equal to A. If A intersection B is a null set, means there is no common set. A is this. If A is equal to A and B are null set, means they have no common element. Then if you want to find A minus B, A there is no common element. So A minus B, there is no common element. It will be equal to A. Okay. So null set means they are disjoint. If A intersection B is null set, that means they are disjoint set. Okay, Ryan? Okay. So A minus B intersection A minus B intersection C. A minus B intersection C will be equal to minus is distributed on intersection A minus B, but this will become union A minus B union A minus C. Left hand side is intersection, but it will become union. Similarly, A minus, if it is union B union C, A minus B union C, so it will become intersection A minus B intersection A minus B. Second property. Yeah. Third, third property is A intersection B minus C. A intersection B minus C will be equal to A intersection B, A intersection B minus A intersection, simple, A intersection C. A intersection B minus A intersection C. Intersection will be distributed inside, so A intersection B, A intersection B, then minus A intersection C. This intersection will go inside with B and C simply. Yeah? And last property, A intersection B symmetric difference C. B symmetric difference C will be equal to A intersection B symmetric difference A intersection C. Simple. This intersection is distributed. Only you have to remember where union and intersection are changing. Hmm. Here intersection is changing to union and union is changing to intersection. Okay. But here no change. Intersection is it is only minus will come between A intersection B, intersection C. B A intersection B, A intersection C, and between difference, symmetric difference will come. So these are the properties which can be asked to prove also. So how to prove these properties? Then we have disjoint sets and complement of a set and some properties of complement. Then we will finish this part and last part will be left. So next class is tomorrow from 9:50 to 10:30. Okay. I will check. I have exam, but let me check first.